Hi everyone, welcome back to the Source of Truth. In the earlier issues, I have spent quite a bit of time talking about the architecture, how we structure data, how we govern it, and how we build retrieval augmented generation systems around trusted information. So, this is something I covered in detail in the last issue 7, talking about the bronze, silver, and gold layers and architecting ChatGPT like RAG environment that you can deploy, use, test in your own system and access online as well. But today I felt there was an important next step. So, what happens when we actually build a multi-agentic AI system and start testing it? So, I have been working on a financial intelligence agentic AI platform, FinQ, where I have been using SEC filings as the underlying information source. So, the objective isn't to claim that RAG is perfectly reliable, it's actually the opposite. I wanted to understand where it works, where it can fail, and what happens at each stage between the original document and the final answer. So, this issue is really about moving from architecture to evidence. So, let's start with the problem. Today, we have access to an enormous amount of financial information. So, companies publish 10Ks, 10Qs, earning disclosures, including risk factors and all those different management commentary and many other financial disclosures. But here is the interesting part. Finding that information isn't same as finding the right information. That might sound weird, but this is what I'm talking about, financial information that's particularly important. AI system can give you an answer about a company's revenue, risk, profitability, or strategy. So I don't just want the model to sound confident, I want to know where did that answer come from? What evidence supports it? That's where the idea of verifiability becomes important. So, the problem I'm going to explore here isn't simply how AI can process more financial information. This isn't just a financial chatbot, but it is how we can use AI to navigate that information while maintaining a connection to the underlying evidence, which is coming from the source of truth, SEC filings. So, this is where FinQ comes in. It has been here all this while. So, I wanted to make one distinction very clear. I'm not presenting FinQ as a finished solution or as a proof that RAG is perfectly reliable. I'm treating it as a learning laboratory. It gives me a very practical environment where I can experiment with the different layers of a RAG architecture and actually observe what is happening beneath the different layers. So I can look at how documents are processed, how they are segmented, how embeddings are created, what gets retrieved, what context is passed to the model, and ultimately what answer comes out, which is what the AI system provide to the user. So my mindset here is really experiment, evaluate, and learn from it. So that's why I think that's an important mindset when we are working with AI systems. Instead of only asking, can we build it? We should be asking, how does it behave? And how do we know when it gets something wrong. So this is where it makes the difference. So now let's look at what's actually happening underneath FinQ. This is the part I find particularly interesting because the final answer is really the result of a chain of transformations. We started with the SEC filings, then we processed and normalized the data. From there, we perform segmentation and chunking, which is essentially breaking a large document into smaller and meaningful pieces. And then those pieces are then converted into what we called as embeddings, which gives us a mathematical representation that allows the system to compare semantic relationships between them. I know this is something really complicated as it may sound, but it's really not that tough. So this is something I'm going to cover in a very easy to understand manner in the coming slide. So when I ask a question, FinQ converts that question into the same type of representation, and it performs vector retrieval to identify potentially relevant pieces of information. That context is then provided to the LLM, which I'm using here from Google Gemini model. So the model generates the financial response based on that retrieved context. So the source of information is very grounded, coming from SEC. And then comes the part that I think is often overlooked, which is the evaluation. So we shouldn't be just looking at the final answer. We need to think what really happened at every stage that led to that particular answer. So this is one of the biggest lessons I have taken away from building this. Every step influences the final answer. So let's take chunking first. If I break a document into the wrong pieces, I may separate information that really belongs together. So the way I chunk the documents affects what the system can retrieve later. Then we have embeddings. So embeddings gives us a mathematical representation of meaning, but that doesn't necessarily mean that representation perfectly captures everything we care about. So if the right evidence never get retrieved, even a very capable LLM doesn't have access to that evidence. And then finally, there is context. Too little context can leave gaps, but too much context can introduce irrelevant information and noise. So when we look at the final answer, we shouldn't immediately blame or praise the LLM. We have to look at the entire pipeline that produced the answers. Semantic similarity is not the same thing as relevance. So here's a simple way to think about it. When we create embeddings, we are representing language mathematically. That allows us to identify pieces of text that are similar in meaning, or at least similar in the mathematical space created by the embedding model. But imagine I ask a financial question and the system retrieves a paragraph that uses very similar terminology, but that doesn't actually contain the evidence needed to answer my question. Mathematically, it may look like a good match, but from a financial reasoning perspective, it may not be relevant. So that is a very important distinction. The algorithm can find something that looks similar without necessarily finding the thing that actually answers the question. So retrieval quality doesn't automatically guarantee answer quality. That is why I think human evaluation still matters, especially when we are dealing with context, intent, and financial nuances. So now the question becomes, how do we actually evaluate these RAG systems? My approach towards this is to think of it as a chain. We first start with the data quality. So is the underlying information complete, accurate, or trustworthy? Then we move to the retrieval quality. That means, did we actually retrieve the information that we needed? And the third one comes is the context quality. So that means, did we provide the model with enough of the right information without adding additional noise? So that is also really important. Then we evaluate generation quality. That means, is the final answer grounded in the retrieved evidence? So does it mean that it comes from a verified source of truth? So this is something that help us think that there is one another level that matters most from a business perspective, which is the decision usefulness. So that means, does this output actually help someone understand a financial question or make a better informed decision? What's the user proposition of it? Because ultimately a technically impressive RAG pipeline isn't valuable simply because it works technically. It has to produce information that is useful for the purpose we are trying to serve. So that is key. This brings the conversation back to governance. For me, governance shouldn't mean putting a checklist around an AI system after it has already been built. It should be part of how we evaluate the system itself. There are three principles I wanted to emphasize here. First, evaluate independently. Don't treat the entire RAG system as a black box. Look at different layers like retrieval, context, generation separately, how they are built from the ground. So that tells a lot about how it is set up. And second is the verification. When an AI system provides an answer, we should be able to understand what evidence contributed to that answer. And the third one is a focus on evidence, which is really important because a confident answer isn't necessarily a correct answer. So what gives an answer credibility is the underlying evidence that we can actually inspect and verify later on as well. And I think that this becomes especially important because we're talking about financial information, and AI literacy and financial literacy increasingly overlap. We need systems that don't just make information easier to access, but also help people understand where that information is coming from. So that is the idea behind this issue 8. I'm not presenting FinQ as the final answer. I wanted to experiment, so the learning will continue. And what I wanted to do with this project was to take the concepts we have discussed in Source of Truth all this while and actually start putting them into practice. We are gone from architecture to retrieval to embeddings and context, and then we have started finally talking about the evaluation piece, the really important layer. So now I'd like to show you what that actually looks like inside the application. So in the walkthrough that follows, I'll take you through the FinQ, show how the different stages work and demonstrate how the architecture comes together when we actually ask a financial question. So let's move from theory so that we can see the system in action.